Hello, this is Mrs. Kraus. I'm putting together a video here today to talk about factoring. So factoring is a skill that we use quite frequently in high school math, and it's also a concept that a lot of students will struggle with initially. Um, in this video, I'm going to talk you through some strategies that you can use when you encounter a factoring problem, and then I'm also going to go through a wide variety of examples so that you can see how I would approach them in a factoring situation. And so before we get started, we want to look at some strategies. So when you're factoring, the first thing you should always be looking for is a GCF. In all factoring questions, that should be your first step. Look for a GCF. And then in class, what we were talking about is we talked about factoring out your GCF. So you would divide your greatest common factor out of every one of your terms, and the GCF would be outside the brackets, and your leftovers would be inside the brackets. And sometimes that's as far as you can go. You just factor out your GCF and then you're done. Other times you can go a little bit further, so you can factor those leftovers even further. So when it comes to factoring, another type that you can come across is binomials. So you're being asked to factor two terms. If you remember, a bicycle has two wheels, a binomial has two terms. And so when we're factoring a binomial, we could pull out a GCF to begin with, but we're ultimately looking for the difference of two squares. Difference means that there's a subtraction sign, and difference of squares means it's a subtraction of two perfect squares. So an example of this might be 4x squared minus 25. Now, sometimes that difference of squares is going to be hidden. You might not recognize it at first because one or more of the terms is not a perfect square. And if that's the case, it means to check for a common factor first. So pull out a GCF. Sometimes by pulling out that GCF, you will find that you have a difference of squares. It was just in disguise. And then you can factor further. Other times you just can't pull anything out, and then it just means it's not factorable. Now, if you come across something like this, a sum of two squares, if you're dealing with the sum of two squares, this is not factorable because there's no situation where we can find two numbers that have a perfect term or have perfect squares in each term, and we get an addition. Okay, and when we get into factoring some examples down the road, you'll see that. Now, when it comes to factoring trinomials, we're looking at three terms, and these are typically the ones that most students will struggle with. So trinomials means that there are three terms, and the methods that we typically will use are guess and check and decomposition. In our class, we've typically done guess and check. You can certainly find other methods like the box method and so on the internet. So now, if I'm looking at a trinomial, the easiest ones to factor are x squared plus bx plus c. That means that there's no coefficient in front of the x except for a 1, or the x squared except for a 1. The ones that are often a little trickier are ax squared plus bx plus c. And this is where we often start getting into the guess and check and the decomposition. With x squared plus bx plus c, then we're looking at a product sum situation. So two numbers that multiply to be c and add to be b. Now, there is one special case you can get, and this is a perfect square trinomial. A perfect square trinomial means that your two factors are going to be identical. So if I were to multiply out a plus b squared, remember you can't just bring the 2 in, we get a squared plus 2ab plus b squared. So if you notice, my first term is a perfect square, my last term is a perfect square, and the middle term is double a times b. And we'd get something similar with a squared or a minus b squared. Now, what if it's not a binomial and it's not a trinomial? There is another scenario that you could come across quite frequently. If there's more than three terms, try to factor by grouping. And sometimes it's just as simple as simplifying your terms first. But if we come across four terms, which is one that you might see, then we're going to factor by grouping. And so factoring by grouping means that you're going to draw brackets around the first two terms, draw brackets around the second two terms, put a plus sign in between, and we're going to essentially common factor twice. And so again, you'll see an example coming up shortly. Now, when you're factoring, a question that I get from my students often is, am I done? How do I know if I'm done? And so to check to see if you're done, you have to go back and look at what your factors are, look in each set of brackets and ask yourself, can I pull out any more common factors? Can I simplify any like terms? Is there anything else that I can take to make this simpler? And if the answer is no, then you're done. And sometimes the most common mistake is that people just miss pulling out another common factor. This will happen if you maybe didn't pull out your GCF completely in the beginning. You pulled out a common factor, but it wasn't your greatest common factor. You may end up finding extra terms to pull out later on. Now, you can also double check your work. So for example, if I had 6x squared, let's try that again, 6x squared plus 3x. And you factored it by pulling out a common factor. So you pulled out a 3, you pulled out an x, and that left you with 2x plus 1. Well, if you wanted to double check that, you would just multiply it back out. So 3x times 2x is 6x squared, and 3x times 1 is 3x. And it matches what we started with, so we know we did it correctly. So again, we just talked about these perfect squares. Perfect squares would look like a plus b squared, and we end up with a squared plus 2ab plus b squared, and something similar for a minus b squared. A difference of squares means there is a subtraction of two perfect squares, so our factors will be a minus b, a plus b, or just as easily a plus b times a minus b, because order doesn't matter when we're multiplying. If you come across x squared plus or a squared plus b squared or x squared plus y squared, this is not factorable. It's a sum of squares and it's not factorable. All right, so let's take a look at some examples, and I'm going to talk you through these the same way that I would approach them if I was factoring them on a sheet of paper. So once we get into Math 20 and Math 30, you're not going to see a page of factoring questions. You're going to be working with word problems where you're going to come across a factoring question, and you'll have to decide how to factor. So I'm going to look at each of these as a group, and then talk about how I would factor each one, and then I'll go back and factor them individually. So the first one here, I've got p squared minus 4p minus 5. Well, this is a trinomial, meaning it's three terms. I do not have a coefficient in the front except for a 1. There is a 1 there, we just don't see it, it's invisible. But since that's a 1, I don't really have to worry about it too much. This is going to be a product sum question. If I look at the next example here, g squared plus 3gh minus 10h squared. This is a trinomial, and there is just a coefficient of 1 in front. So it's also a product sum question. So it's a factoring of a trinomial, but it's product sum. Now here we have 4 terms, so likely this is going to be a factor by grouping question. And the fourth one, I've got m squared minus n squared. There are 2 perfect squares and a subtraction sign in between, so this is a difference of squares. All right, now that I've identified how I'm going to factor them, I'm going to go up and actually factor. So for the first one here, I've got p squared minus 4p. So I'm going to be looking for 2 numbers that multiply to be negative 5. So they have a product of negative 5 and a sum of negative 4. So I start with my 5 and I think about my factors of 5. Well, in this case, I've only got the 2 factors, 5 and 1. And from that 5 and 1, I need a product of negative 5 and a sum of negative 4. So a product means that I'm going to multiply the 2 numbers. So I need to multiply the 2 numbers and get a negative. That means that my signs are going to be opposite. And I want a sum of negative 4, so that means my bigger number has to be negative. So negative 5 and positive 1. So when I'm factoring, I'm going to set up my 2 brackets. I start with the front bracket. I need to get a p squared. So I'm going to try to figure out 2 numbers that multiply to be p squared, or in this case, variables. So p times p is p squared. And my 2 numbers that multiply to be negative 5 and have a sum of negative 4 is a negative 5 and a positive 1. So there's my factors, p minus 5 times p plus 1. And again, you could multiply those out to double check your answer. For the next one here, I've got g squared plus 3gh minus 10h squared. So I'm looking for 2 numbers that multiply to be negative 10h squared and add to be positive 3gh. So off to the side, I'm going to factor 10. I've got 5 and 2 and 10 and 1. And I want 2 numbers that are going to multiply to be negative 10 and a positive 3. Negative 10 means, again, my signs will be opposite, and a positive 3 means my smaller number will be negative. So I'll set up my brackets again. We've got a g and a g. So g times g gives me g squared. And negative 10h squared. Notice there's an h squared there, so that means I'm also going to have a variable in that second term. And so we've already decided we're going to have a positive 5h and a negative 2h. Again, order doesn't matter. I could have also written g minus 2h times g plus 5h. All right, looking at the next one here, we've got factoring by grouping. So we've got 4 terms. We're going to bracket the first 2 terms, bracket the second 2 terms. Notice I contained that plus sign. I'm still going to put a plus in between. If this had been a negative sign, I want to keep that contained. I still put my plus sign because one of my first steps will be to factor out that negative. So I'm going to do common factoring here. So I'm going to just put CF or GCF. So I'm going to pull out an M out of the first term, and that's going to leave me with M minus 4. Out of the second term, I'm going to pull out a positive 2, and I'm going to pull out an N, and that's going to leave me with M minus 4. Now you should notice that here M minus 4 and M minus 4 are the same, so that's my common factor. So we're going to do a GCF again, or common factor again. So we pull out an M minus 4, and that leaves our leftovers as M plus 2N. Now, this factoring by grouping is actually a step or a process that we use when we're factoring using decomposition, but we don't see it terribly often. Typically, factoring trinomials is what we see most commonly. All right, so the next one here, we've got a difference of squares, so m squared minus n squared. Well, this isn't really a step that we do. A lot of times I'll see students put the square root signs over there, and that's just a reminder to themselves that we're essentially square rooting those first and last terms. So square root of m squared will be m and m. So we square root that first term, and it goes into the first bracket. And then we're going to square root the last term, so n and n. And then in order to have our middle term cancel out, we need a negative product, meaning they're opposite signs. And by having identical brackets with just opposite signs, my middle term is going to cancel out. So I've got m plus n times m minus n. So again, you're just square rooting those first terms, square rooting the last terms, and then plus minus. All right, so we're going to come across 4 more examples here. Again, I'm going to go through them and talk through where I will be going with them. So the first one here has 2 terms, so it's a binomial. So I'm probably going to be looking at a difference of squares. And I haven't even looked yet to see if I have perfect squares. I just know that it's a binomial, and I've got a subtraction sign, so it's probably difference of squares. The next one here, I have 15y squared plus 20y minus 25. It's a trinomial, but I have that number in front. So I'm still always going to look for a GCF. I'll start by looking for a GCF, and then I'm probably going to be either doing product sum or guess and check. But I do have to start off with a GCF because I can see a 15, a 20, and a 25. I can probably pull something out of there. So GCF and then probably product sum or guess and check. Now decomposition will always work as well here. Here I've got 3u squared minus 10u plus 3. I can't pull out a GCF, so it's probably either going to be guess and check or decomposition. Either of those methods will work. And then for the last one here, 2w squared plus 21w plus 27. This is again going to be guess and check or decomposition. So again, anytime we have the trinomials, if we can't do product sum, it's going to be guess and check or decomposition. So let's go back up to the first one here. If this is a difference of squares, that means my first term is a perfect square, and so is my last term. And in this case, they are. So I can square root my first and my last terms, set up my brackets. Square root of 9a squared is 3a, so that goes in my first bracket. Let's try that again. Three a. And square root of 16b squared is 4b. So don't miss those variables. They're important as well. And plus minus or minus plus. All right, the next one here, we're going to look for that GCF first. So I've got 15, 20, and 25, so I can pull out a 5. And so we're dividing each term by that GCF. In our brackets, we'll have our leftovers. 15 divided by 5 is 3. And that leaves me with y squared. 20 divided by 5 is 4. Y minus 5. All right. So the most common method that we've been using in class is guess and check. So that's the one I'm going to work with first. With guess and check, what you're doing is you're looking for factors of the 3, which is 3 and 1, and factors of 5, which is 5 and 1. And then we're going to play with those numbers until we can get a combination that gets us to a 4. The reason it's called guess and check is because it's basically trial and error. But the better you know your math facts, the less guess and check that's actually involved. So let's look at some combinations. 5 times 3 is 15. 1 times 1 is 1. Will 15 and 1 get me to a positive 4? The answer is no. So then I look at 1 times 5 is 5, and 3 times 1 is 3. Will these get me to a 4? The answer is no. There's no combination that I can use that's actually going to get me a negative 5 and a positive 4. So we're actually done at this point. That is the last we can go. So our final answer is just 5 times 3y squared plus 4y minus 5, because we can't go any further. All right, let's take a look at another one here. So 3u squared minus 10u plus 3. So again, we're going to be looking for two numbers, we're going to be looking for numbers that multiply to get 3 and multiply to get a 3 at the end. If I'm using guess and check, I'm just going to set these up. I'm looking for factors of 3, 3 and 1, factors of 3 are 3 and 1. And I can't pull out a common factor, so I should have checked for that in the beginning. I'm just going to play with my combinations. So 3 times 3 is 9. 1 times 1 is 1. Will a 9 and a 1 get me to a negative 10? Probably. So let's try that first. So we're going to write 3u and 3u. And then I'm going to write 1 and 1. I'm going to set up my line. Notice I haven't even looked at my signs yet, but I do know here I need a positive 3. That means my signs have to be the same. And I need a negative sum, so that means they're going to be negative. So 3u minus 1, 3u minus 1. But I need to check to see if this works. When we're multiplying out our brackets, we never multiply within the brackets, we multiply across. So 3u times negative 1 is negative 3u. And 3u times negative 1 is negative 3u. Now, I'm not sure if you noticed, but I mixed up my numbers as I was writing them down. So this is not actually going to work. Negative 3u and negative 3u is negative 6u. So we're going to take the eraser and we're going to try something else. Originally, when we were looking at the numbers, I had said 3 times 3 and 1 times 1. So let's try setting them up this way. So if I'm going to use 3 and 3, that means they cannot go top and bottom like this. So I have 3u and 1u. So that mistake was actually not intentional, but it does point out a common mistake that some people can make. So 3u and 1u. 3u and 1. And we want to multiply our 3u and our 3 together. And we want to multiply our 1u and our 1 together. And so we multiply across again. 3u times 3 is 9u. And 1u times 1 is 1u. Now, we need a negative 10 and a positive 3. So that means they're going to be the same sign, but they're going to be negative. So a negative 1 and a negative 9. And if we add those up, we get negative 10u. So our factors are 3u minus 1 and u minus 3. All right, let's take a look at the next one. Again, I'm going to keep using guess and check. Near the end, I'll try to do a decomposition question. But 2w squared, we're looking for two numbers that multiply to be 2. And then we're looking for two numbers that multiply to be 27. Well, 27, I have a couple more options. I've got 27 and 1, and I've got 3 and 9. And again, I'm going to be looking for my combination that will get me to a positive 21. So I want a positive 21 and a positive 27. So I don't really have much choice with the 2. I'm going to have a 2w and a 1w. But off to the side here, I have a couple more options. So let's play with some numbers here. 2 times 3 is 6. 9 times 1 is 9. Will a 6 and a 9 get me to 21? The answer is no. Well, what about a 2 times a 9? That's 18. And a 3 times 1? Will 18 and 3 get me to 21? And the answer is yes. So we want the 2 to be multiplied by the 9. So it's going to go down here. And we want the 1 to be multiplied by the 3. So it's going to go here. Again, notice I haven't looked at signs yet. 2 times 9 is 18W. And 1W times 3 is 3W. This is when I look at my signs. I want a positive 27 and a positive 21. Well, in order to get a positive product, I need the same signs. And in order to get a positive sum, those signs have to be positive. So my factors are 2W plus 3 and W plus 9. All right, let's take a look at a few more examples. So looking at these ones here, the first one I have a binomial, and it looks like I can definitely pull out a GCF. So I'm going to start with my GCF always, and then see if I can go any further than that. So I've got k squared plus 7k. Well, I pull out a k, and again, I'm dividing both terms by that GCF. Pull out a k squared divided by k is k, and 7k divided by k is 7. I can't go any further than that. There's nothing else that I can pull out, no other common factors, and no like terms to simplify, so I'm done. Next one, again, we always start with GCF. I can see I've got an 18 and a 27. If ever you're stuck with your factors, you can always write them down. 27 is 1, 3, 9, and 27. And 18 is 1, 2, 3, 6, 9, and 18. Well, our greatest common factor for the numbers is 9. So I can pull out a 9. I can also pull out an A. So I'm going to divide by 9A. And I'm going to divide by 9A. Well, 27 divided by 9 is 3. The A divided by A cancels, and I'm left with a B. Negative 18 divided by 9 is negative 2. A divided by A cancels, and I'm left with a C. Again, no other common factors I can pull out, and no like terms that I can combine, so I'm done. Looking in the next two here, I've got 9x squared minus 12x plus 4. So I can do this using guess and check, or I can do decomposition. So I've already done a couple guess and check questions. I'm going to use this one, or solve this one doing decomposition. Now when we're doing guess and check, we look at each term individually. We look at the first term, we look at the last term. When we're doing decomposition, we actually look at these two terms together. So we're going to be looking for numbers that multiply to be 36. So for 36, we're going to have 1 and 36. We're going to have 2 and 18. We're going to have 3 and 12. And we're going to have 4 and 9. And we're looking for two numbers that multiply to be negative 12. And if I'm looking here, I've got one more. Missed one more factor, and that would be 6 and 6. All right, so the numbers that are going to multiply to be 12 are 6 and 6. So setting up my factors with decomposition, what we do is we actually decompose that middle term. So we write them out here. And so we're going to have 9x squared, and then we've got to deal with these 6's. We want a positive product and a negative sum. So that means the same signs, but we want a negative sum, the same signs, we want a negative sum, so we're going to be subtracting. So 9x squared minus 6x plus 4. So 9x squared minus 6x plus 4. That's that decomposing. We're decomposing the middle term. Now, we're going to factor by grouping. So we're going to group our first two terms, group our last two terms. Notice I contained that negative sign, put a positive in between. And then we're going to factor out a GCF. So here I can pull out a 3, I can pull out an x. 9 divided by 3 is 3. X squared divided by x is x. Negative 6 divided by 3 is negative 2. And x divided by x cancels. Whenever my first term has a negative, I'm going to pull that negative out. And I can pull out a negative 2 here. And that leaves me with negative 6 divided by negative 2 is a positive 3. X positive 4 divided by negative 2 is minus 2. If you factored correctly, and this is factorable, you should notice that your terms in the brackets are now identical. So I have a common factor of 3x minus 2, and I've got leftovers of 3x minus 2. And so this happens to be a perfect square trinomial, 3x minus 2 squared. And so if you notice up there, 9x squared was a perfect square, 4 was a perfect square, and in the middle, this is double 3 times 2, or 3 times negative 2. All right, so decomposition is a totally valid method. I'm not going to show any more decomp questions because decomposition takes a lot of time. And so, especially when you get into 20 and 30, I find that the guess and check method is significantly faster. However, both methods are valid, and as long as you can factor the question, the method does not matter to me. All right, so let's take a look at this one here. We've got 4c squared plus 4cd plus 35d squared. First of all, I look for a common factor. There is no GCF that I can pull out of here. So the next thing I look for is, can I do numbers that multiply to be 4 and numbers that multiply to be 35? So I have 35 in 1 and 5 in 7. Ultimately, I'm still going to need that product and the sum. So I'm looking for a combination of numbers that will get me to a sum of 4. So we start with 4 and 35. Well, I've got a really small number, so I definitely am not going to start with 4 and 35. But I could try 4 times 35 and 1 times 1. The answer is no, it doesn't work. So then I could try 1 and 35. Well, still looking at that sum, I know that's probably not going to work. So I go with the other combinations. 4 and 5 is 20. 1 and 7 is 7. Will a 20 and a 7 give me a sum or difference of 4? The answer is no. What about 1 times 5 and 7 times 4? Well, 1 times 5 is 5. 7 times 4 is 28. That doesn't work either. So this is an example of a question that's not factorable. We couldn't pull out a common factor, and none of our combinations of numbers worked, so this one's not factorable. All right, we've got 2 final examples here. So let's look at the first one. Anytime I have a first term, when this is written in algebraic order means I write the x squared first, then the x, and then the constant. But anytime I have a negative in the first term, I want to pull that negative out. And in this case, that's all I can pull out is a negative 1. And then I'm left with 6x squared plus 25x plus 25. Because when I divide something by negative 1, my signs are going to change. So now I'm looking for factors of 6. So I've got 6 and 1 and 2 and 3. And factors of 5 are 5 and 5. Again, I'm going to play with my combinations of numbers. 6 times 5 is 30. 1 times 5 is 5. Well, that's probably a good place to start. So I'm going to start there. 6x and x and 5 and 5. 6x times 5 is 30x. X times 5 is 5x. Now, I need a positive sign, a positive product, and a positive sum. This will not get me there. So a positive 30 and positive 5 won't work, and a negative 30 and negative 5 won't work. So I'm going to erase that option. That's not going to be the one I want. And let's try some other combinations. So I could go 3 times 5 is 15, and 2 times 5 is 10. 15 and 10 will work. So 2x and 3x. I wanted to multiply the 2 with the 5 and the 3 with the 5. 2x times 5 is 10x. 3x times 5 is 15x. I need a positive product and a positive sum. That means they have to be the same signs and they have to be positive. So if I check, 15 plus 10 is 25x. So sometimes it will happen where you come across combinations that work initially, but once you look at the signs, they don't work. So here I've got 2x plus 5 and 3x plus 5. And as you get quicker with these, you might not write out your chart right away. You'll just go straight to playing with the numbers, playing with the signs, and then writing out your choices. All right, the last one we have here, we've got 9x squared, or 9x to the fourth minus x squared. Well, it's a binomial, so I'm still going to start with my GCF, but after that, I'm likely looking for a difference of squares, okay, because I see a subtraction sign, and I've only got the two terms. So the first thing I do is pull out a common factor. There's no numbers that I can pull out, but I can pull out an x squared. If I pull out an x squared, that's going to leave me with 9, and x to the fourth divided by x squared is x squared. And this is a common mistake. People will divide this and just leave it as 0. If there are two terms in the original question, there should be two terms in my leftovers. So negative x squared divided by x squared is a negative 1. And so if I factor this, I'm going to have x squared. This is now a difference of squares. 9x squared, the square root of that is 3x plus 1, and 3x minus 1. And so again, this is an example where we factored our GCF, we have our leftovers, but then we have to go one step further. Be careful not to forget to bring that GCF along for the ride. All right, there's our final answer, x squared times 3x plus 1 times 3x minus 1. So there's lots of different factoring examples that you're going to see. Hopefully this gives you a taste of what you could see. So we can have everything from trinomials to binomials, some that we just have to pull out a common factor. There is going to be the odd time where you come across ones that are not factorable. But ultimately, when you're approaching a factoring question, start off by looking at what you're being given. Is it a binomial? Is it a trinomial? And then try to employ some of those strategies that I gave you at the beginning. Best way to learn how to factor is to practice. So feel free to go through this video as many times as you need. Good luck and happy factoring.